Chapter 10.6, we are looking at eliminating angle parameters. So it isn't necessary for the parameter in a set of parametric equations to represent time, as we did in the previous example. The next example uses an angle as a parameter. So sketch the curve represented by each set of equations by eliminating the parameter. So we know that the first equation, the first one we're working with is x equals 3 cosine theta and y equals 4 sine of theta, and theta is between 0 and 2 pi. So first, let's go ahead and isolate our cosine of theta here. So if we divide by 3, we get cosine theta equals x over 3. Then for sine, if we divide by 4, we're going to get sine of theta equals y over 4. And then what we're going to end up using is the Pythagorean identity, so our trig identity. So cosine squared of theta plus sine squared of theta equals 1. So let's substitute. We have x over 3 squared plus y over 4 squared, and that equals 1. And so we're looking at x squared over 9 plus y squared over 16 equals 1. And so what does this graph look like? So hopefully remember, this looks like an ellipse. So we know that it has a vertical major axis. The A value is 4, which is here, and B is 3. We know it's centered at 0, 0. So it's centered at 0, 0 here. So we know that it's up 4, down 4, left 3, right 3 here. And so we know this is our graph. Okay, so that's our equation, and here is our graph. Now we need to know what direction it moves. We know that it's theta has to be between 0 and 2 pi. So here is 0. And then again, we're just plugging in. We're going to, for our x value, we're plugging in the theta here. So x equals 3 cosine of theta. And then for our y values, we're plugging in from here. So y equals 4 sine of theta. So just plug in theta in each of these equations. So we have when cosine is 0, that means it's 1, right? This is 1. So 3 times 1 is 3. Then at sine of 0, that is 0, so this ends up being 0. Next, what are we going to plug in? Well, let's plug in pi over 2, and then pi and 3 pi over 2, and then maybe 2 pi. So then at pi over 2, cosine of pi over 2 is 0, so that is 0. 0 times 3 is 0. At sine of pi over 2, that is 1, so 1 times 4 is 4. And then at pi, cosine is -1, so 3 times -1 is -3. And then sine is 0 at that point. At 3 pi over 2, cosine is 0. And sine is -1, so -1 times 4 is -4. And at 2 pi, so we're back at the beginning again, it's the same exact number here. So cosine is 1, 1 times 3 is 3, and then y is 0. So this tells us the direction or orientation of our curve. So we know that at theta equals 0, that is here. And then when theta equals pi over 2, we are now here. And so the curve is moving in this direction. Okay, let's do one more example. So x equals 1 plus 3 secant theta, and y equals -3 plus tangent theta, and theta is between pi over 2 and 3 pi over 2. So looking at that, we know we're only looking at quadrants. The values we're looking at is quadrants 2 and 3. That tells us that our domain is all negative values, so x is less than 0 in this case. So let's go ahead and solve here. So let's isolate our secant of theta. So subtract 1 from both sides. So x minus 1 equals 3 secant of theta. Then let's divide by 3. So I'm going to rewrite it. Secant of theta equals x minus 1 over 3. Doing the same thing for tangent, we find that tangent of theta equals y plus 3. So let's think about our trig identities. We know that it is 1 plus tangent of theta, tangent squared of theta equals secant squared of theta. So we subtract tangent squared of theta from both sides, and so we know we are going to use the trig identity secant squared of theta minus tangent squared of theta equals 1. So let's plug everything in. So secant, we know it's x minus 1 over 3, and that's squared, minus tangent of 3 is y plus 3 to the squared, and that equals 1. So to simplify this a little bit, we know that we have x minus 1 to the square over 9 minus y plus 3 squared over 1, and that equals 1. So this is subtracting, and so what are we looking at? We're looking at a hyperbola. Now, thinking of our restrictions, x can only be negative. We know that our hyperbola is centered at 1, negative 3. So here, we know that our a value is 3. So that means it's 3 to the left of the center and 3 to the right. Now, in this case, we know that the x has to be negative. So really, we can disregard this vertex here. We're only looking at the vertex at the left. So we're going to say that x has to be less than negative 2. Now, in order to get the rest of these points, we are going to, again, plug in our values for x and then our values for y. So we have to think about what theta we want to plug in. Now, theta we know has to be between pi over 2 and 3 pi over 2, right? So pi over 2, let's try. So pi over 2, let's try 2 pi over 3, and then let's try pi, and let's try 4 pi over 3. So those are the values that I'm going to plug in into our x and y here to try and figure out where my points are for this graph. So for x equals 1 plus 3 secant of theta, and we're going to plug in 2 pi over 3. So this is x equals 1 plus 3. I'm going to think about this as cosine of 2 pi over 3. Cosine of 2 pi over 3, we know that is negative a half. So it's 1 plus 3 over negative a half. And then, so we flip and multiply, we end up being 1 plus 3 times negative 2. So 1 minus 6 is negative 5. Then we plug it into our y value. So we have negative 3 plus tangent of 2 pi over 3. So that is y over x. So that's going to be root 3 over 2 and a half over a half. So we're really looking at, and this is negative, right, because it's in quadrant 2. We're looking at negative 3 minus square root of 3. Now at pi, if we plug in pi here, so at pi, we know that secant of theta is going to be negative 1. So this is negative 3 plus 1, which is negative 2. Then for our tangent, we know that is going to, tangent at pi is going to be 0. So this is just negative 3. And then if we plug in 4 pi over 3, so it's very similar to here. And so our x value will be the same. It'll be negative 5. Now what's going to change is our tangent of theta. So just to kind of do that work over here on the side is if we have negative 3 plus tangent of, and our theta I said was 4 pi over 3. And so we're down here. So I mean tangent is going to be positive. And so that is going to be root 3 over 2 over a half. So we're looking at negative 3 plus root 3. All right, so let's plot some of these points. So we're at negative 5, negative 3 minus root 3. That's a little over negative 4 something. So negative 5, x is negative 5, and then negative 4 point something. We're looking at somewhere down here. And then that is at theta is 2 pi over 3. Then notice at pi, it's going to be at negative 2, negative 3. So then we know that it's going in this direction here. And then on the other side, the parabola, the hyperbola is going to be somewhere over here. Okay, and that's at theta equals 4 pi over 3. So then that helps us with the orientation of our graph. So go ahead and try this example here. Sketch both represented by the set of equations by eliminating the parameter. So try these out. So the first one would be an ellipse with a horizontal major axis, and then the other one is still a hyperbola, but this one is open down. And then just note the values that I plugged in as well as what direction the curves are moving.